In this brief video, we're going to go over how to use the z-table when we compute a z-value. And so we'll start with just something that we left off with in a previous lecture, and that's how to calculate a z-score. And so in order to calculate a z-score, we need three things. We need a raw score from 1 unit or person, and we need some sample statistics that were generated. Those sample statistics include the average for a group of scores. So if we have a sample size of 16 people from which we obtain some data, and we average out those data, we would come up with the sample mean, and then we have to obtain the sample standard deviation as well. So there are only two sample statistics in the z-score calculation and one raw score. So just to review from a previous lecture, for the number of participants we have in a research study, we will have the same number of z-scores since they're computed individually. So the advantage of calculating the z-score, as mentioned previously, it assesses the position of each unit in the sample, and it eliminates the unit of measurement. And so this would allow us to compare between different dependent variables. But then how can we use the z-score in order to determine a percentile ranking of only one unit in that sample, or even of all units in that sample? And so that's where we go to the z-table. And so we have our z-table, which is a measure of what's called the area under the normal curve. And so what you see here is the typical normal curve that we've observed previously. And so we know that the normal distribution, or the normal curve, is centered at 0. So about 0, which is where the mode, median, and mean of our sample resides. And recall, on the y-axis, we have the count, the number of occurrences at each of the dependent scores. Now, the entire scale of a dependent variable has been converted to the z-scores using the previous calculation. And so in going to the table to determine the percentile, we see three columns. Here we see the z column, and this is the actual z-score computed from the previous equation. And so we'll end up with a particular value, and then we move to the next column, and the next column is the area between 0 and the calculated z-score. So if we go back up to our normal curve, if we were able to measure the area, and we can measure the area, but we won't go through the mathematics, but if we measure the entire area under this curve that extends way out into the tails, that area has a value of 1.0, or 100% of the area. And so what we calculate here, or what we look up here in the z-table, is the area between 0, that middle point, that symmetry, that point about which we see symmetry, and the computed z-value. The third column is a measure of the area outside of the z-score, and we'll go through an example here. And so we'll come back to the z-score of 0 in a moment. And so let's suppose we go through a sample. We have 16 participants. We identify one participant, and that one participant has a z-score of 0.85. That's what the equation gave us. So we go to the z-table, and we look up a value of 0.85. And we find 0.85, and we see the corresponding area between 0 and 0.85, and the area outside of that. Now we go up to our z distribution, and we find 0.85 resides somewhere here. It's actually quite precise, but for our purposes, I estimated the position at around this point right here. And so when we talk about the area between 0 and z, we're referring to this region right here. And this region has a value of 0.3023. If we express that as a percentile, move the decimal place over twice, we have 30.23%. So if the entire area under the normal distribution is 100%, this region here represents 30.23%. Now, if we move over to the next column, we see the balance is 0.1977 or 19.77% is captured in this area, right here. So we see much more area in this region and less area in this region. Now we come back to this previous highlighted row here. Here we have, if we calculate a z-score of 0.0, what does that mean? We'll go back one slide. And so if our z-score equals 0, it means our numerator was 0. How can the numerator equal 0? The numerator equals 0 when a single raw score of one person out of the 16 in our sample has a value that is exactly equal to the sample average. And if that's the case, the person's score is exactly average, and that score will lie right along that line of symmetry. And so naturally, the area between 0 and the z-score of 0, which is 0, is going to be 0. Now the area above that will be 0.5 or 50%. So to calculate the percentile, we always have to add 50% if we're on the right side of our 0, our line of symmetry. If our calculated z-value is less than 0, so if it's a negative value, then we would not add 50% in order to compute the percentile. We would use the area outside of that z-score and that area between 0 and z as the percentile point. So this ends this very brief video on how to use a z-table.